This is part 2 of the instructions for the mini lab entitled The Orbit of Mars. Once you have your chart or your graph completely constructed like so, the next thing to do is to estimate the eccentricity of the ellipse. So I've plotted here roughly what your 8 points will look like here for the orbit of Mars from part 1 of this exercise. Notice that if you look at the curve that would eventually connect all of the red points here, it would definitely be non-circular. It is definitely elliptical, and now we'll just go through an estimation process of calculating the eccentricity of the orbit. What you should notice off to the lower right-hand side of your graph or your chart, once you've completely constructed it, is that one of the positions of Mars here is noticeably closer to the sun than the other points. What we're going to simply do is estimate that point as perihelion, the closest approach of Mars to the sun. So the first thing to do is estimate perihelion. We're going to assume that that's this point right here. And then what we're going to do is draw the major axis of the ellipse from that point passing through the sun out the other side of the ellipse. That will then look like this. Like so, to about here. When you draw this axis out towards the other side of the ellipse, you'll notice that it does not intersect one of the points. However, it will be close to a couple of the points on this side of the diagram. What I'm going to do is I'm just going to estimate approximately where aphelion is here on my diagram. Okay, next we're going to make a couple of measurements. The first distance that you're going to measure is this distance here from perihelion to aphelion. This is the major axis, which we're going to call 2A. Measure it in terms of centimeters. Okay, once you've measured it in terms of centimeters, divide it in half and then get the semi-major axis A. Use that distance then to locate where the center of the ellipse is. Measure that distance from the perihelion position. So from perihelion to the center of the ellipse, the distance A, we'll say is approximately right here on my diagram. The sun, if you recall, is not at the center of the ellipse, is at the focus. So then therefore we locate the center. I'm going to say on my diagram that that is about right here. So then the next step is to calculate A, measure, locate the center of the ellipse. Okay, so right here is the center. Let me go ahead and write it as such. Like so, where the sun is located, that's the focus. And then the next thing that we need is this distance from the center to the focus. That distance right there is EA. So use a ruler in terms of centimeters to measure this distance. This distance here is EA. Okay, so now if we have the distance EA, and you know what the distance A is from earlier, then the last step to find the eccentricity is just a little bit of division. So now calculate the eccentricity E. Take the distance EA and divide it by A. So take your distance for EA in terms of centimeters, divide it out by the distance A in terms of centimeters. What's left over is the eccentricity E. Okay, you should end up with a value of about 9%. Even though we are making lots of simplicities when constructing this lab exercise, if you did this lab exercise carefully, you should still get a pretty good result. What I want you to do is I want you to show all of these measurements and calculations on this portion right here of your diagram. Make sure that you also put your name on your diagram as well. Photograph the entire diagram, scan the entire diagram as a single PDF, and then upload it to the assignment on Schoology. Thank you.